The incomparable red spot in the world Jupiter is the biggest tempest on any planet in the whole planetary group. In the past it was much greater than it is now. The sheer profundity of it is difficult to handle. To give you an idea, it's like having around 45 Mariana Trenches stacked on top of one another. On Earth, hurricanes rapidly lose their strength while moving over land, but on Jupiter there is no land, so there is no contact to dial back the monstrous tempest. It's been seething for hundreds of years, yet something odd is going on with the incomparable red spot. Since the late 19th century, it has contracted fundamentally, advancing in size, shape, and even tone. From its starting points as an immense oval more than 3 times the width of Earth, to its current aspects, roughly 10,000 miles wide, the incomparable red spot storm has taken on a more round shape, while its colors have been going from pale to serious red-orange tints. Researchers believe chemicals like ammonia and hydrocarbons in Jupiter's upper layers may be responsible for these colors, though the exact elements remain unclear. But no matter how magnificent the incomparable red spot is, it is only one captivating feature of the gas monster. Jupiter's air is a whirling blend of belts, zones, and tornadoes with strong east-west winds separating the particular cloud groups. It makes up just 1% of the planet's mass, but it's extremely complex, and the cycles behind its particular features aren't yet totally clear. The giant gas planet is famous for its jet streams or generally stable winds. Some of them reach speeds of 320 miles per hour, are more than 3,000 miles wide, and extend over 1,850 miles beneath the planet's clouds. It would seem that while comparing Jupiter and Earth, they are 2 entirely different planets. But shockingly, there is something that unites the 2 worlds. When researchers studied the chemicals present in Jupiter's atmosphere, they observed an abundance of ammonia and its complex distribution. Some regions have much higher concentrations, and there are even ammonia segments extending from deep inside Jupiter up to its top cloud layers. Using data from NASA's Juno spacecraft, researchers realized that the way Jupiter's upper and lower atmospheric layers interact results in a vertical flow, something that also happens here on Earth. A fell cell is a type of wind pattern, and there are 2 of them on Earth. On our planet, they are called Hadley cells near the equator, which move warm air up toward the poles, while polar cells bring cold air down. In between, the fell cells behave like a cushion zone. They turn the other way to different cells, creating a crisscross pattern of wind going through each side of the equator. However, the largest planet in the solar system has 8 such patterns. These cells align with the normal boundaries of what we could call Jupiter's version of Earth's fell cells. According to researchers, this is the secret to Jupiter's famous color bands, forming on the gas giant. The wind patterns are different from Earth's primarily because Jupiter doesn't have a solid surface. However, scientists believe they found something intriguing a few miles beneath the gas giant's cloud cover that could behave like a stable layer, like Earth's surface. Based on computer models, something seems to be slowing down the winds in circular patterns on Jupiter. One theory of what that could be is tall vertical versions of Earth's fell cells. These cells could influence how the winds move, causing odd phenomena like ammonia forming into slushy oval shapes, extending 60 miles deep into Jupiter's atmosphere. As ammonia rises, it gets colder and forms icy clouds in the higher parts of the atmosphere. The air that remains sinks down, but it doesn't have much ammonia left in it, which creates a kind of column where the ammonia is mostly at the bottom and lessens as you go higher. An ammonia-water solution is also responsible for lightning, which generally occurs near the planet's poles. And then, there are fierce storms that sweep across Jupiter's enormous atmosphere. Jovian storms are intense, and they might lead to unusual hailstones rich in ammonia, which scientists call mush balls. Mush balls on Jupiter are believed to form when rainstorms lift water ice crystals upwards, reaching levels of more than 16 miles above water clouds. There, they encounter ammonia fumes, which melt the ice and form a unique mixture of ammonia and water. The process occurs at temperatures below -16 degrees Fahrenheit, where liquid water can't exist. But the presence of ammonia acts as a radiator fluid, allowing the formation of liquid drops inside these newly formed clouds. Drops of ammonia water fluid can crash into the rising water ice crystals, charging the clouds and creating lightning. As the mush balls grow larger, they accumulate layers of slush and ice, becoming increasingly heavy. Eventually they become too large, plunging deeper into Jupiter's atmosphere, where they face hotter temperatures and disappear. This shows just how much more complex Jupiter's atmosphere is compared to what we once imagined. In the past, researchers studied the most prominent features of Jupiter: its colorful bands, the incomparable red spot, and its dark and bright patches. However, we know very little about what's happening inside the giant beneath its atmospheric cover. Gas giant planets likely don't have solid inner layers like those common among Earth-like planets. It's just a slow transition from the atmosphere to the planetary core. Let's imagine you fell into Jupiter. What would you see and feel as you dropped through the planet? Well, most importantly, it's a gas giant, and that means you'd continue falling deeper and deeper without ever landing on a solid surface. The fall would feel so long, and it wouldn't be long until you die. Even before getting near Jupiter, intense radiation would enter your suit, which would spell almost certain doom for you. So, you'd need an advanced radiation-proof space suit that could offer some chance of survival in this harsh environment. On Earth, falling objects typically advance by around 32 feet per second every second. But as you plunge to the top of Jupiter's atmosphere, your dropping rate, something known as terminal velocity, would be around 2,000 miles per hour, much faster than a fighter jet on full afterburner. At a certain point, you would enter the region of ammonia clouds, where temperatures drop to a frigid -240 degrees Fahrenheit. Jupiter's clouds churn with intense winds, reaching speeds of up to 425 miles per hour, so you'd be tossed around like a leaf in a cyclone. On top of that, the gas giant's upper atmosphere rotates at 110,000 miles per hour. At this speed, if you happen to slam into a thick gas cloud, it would be like hitting a solid wall. Later in your fall, if you survived the earlier obstacles, you'd see clouds changing color. These clouds contain ammonium hydrosulfide and ammonium sulfide, giving them a brownish color, which becomes more intense the further you fall. At first, the pressure around you would be bearable, even for someone without a space suit, like being 100 feet underwater on Earth. But eventually, the pressure would reach multiple times the Earth's air pressure. For now, though, you've reached clouds of water. While a space suit could protect you from the external pressure, it can't prevent the physiological effects of breathing gases at high pressures. At multiple times Earth's pressure, breathing normal air becomes incredibly dangerous due to oxygen toxicity and nitrogen narcosis. Oxygen toxicity occurs when the body is exposed to high levels of oxygen for a prolonged period. Additionally, at higher pressures, breathing air with increased oxygen levels can lead to the formation of reactive oxygen species in the body, damaging cells and tissues. This can result in symptoms ranging from mild discomfort to seizures, and it could have fatal consequences. Nitrogen narcosis occurs when nitrogen gas dissolves into the bloodstream under high pressure, affecting brain function, much like alcohol or tranquilizers. Nitrogen narcosis can cause impaired judgment, euphoria, and altered perception. But it can also advance to more serious symptoms, including confusion, hallucinations, or loss of consciousness. Both oxygen toxicity and nitrogen narcosis are affected by pressure, because pressure influences the solubility of gases in the bloodstream. As pressure increases, the amount of oxygen and nitrogen dissolved in the blood also increases. To avoid this, your spacesuit would need to adjust the air mixture you breathe to maintain safe oxygen and nitrogen levels, adding helium or neon to the mixture. And this is just the beginning of your long drop into Jupiter. As you fall deeper, it gets darker due to the rising pressure. Visibility becomes limited because of the thick and hazy nature of the gas giant's atmosphere, through which light struggles to penetrate. As light enters, it gets scattered and absorbed by the thick gases and particulates, resulting in a murky and dim environment. Even if your spacesuit is equipped with a strong light source, it would still be hard to see more than a few feet ahead. You'd need special equipment and sensors to detect the surrounding environment. If you somehow manage to survive the intense pressures, more than 400 miles below Jupiter's atmosphere, you'd enter the domain of the gas giant that has never been explored. However, no communication with Earth or even a nearby satellite would be possible. All radio waves would be absorbed by Jupiter's thick atmosphere. The whole excursion toward the gas monster center would assume control over 20 hours. However, partially through, you would now be presented to temperatures hot enough to liquefy tungsten, a grayish-white metal with the highest melting point among metals known to science. Meanwhile, pressure increases drastically, so there's absolutely no way you could endure this. The increase in pressure and tension would also act against your downward movement, dialing back your fast drop. It's like trying to travel through thick mud or syrup. The denser the substance you're traveling through, the harder it is to continue moving rapidly. So, regardless of gravity pulling you downwards, the rising density of Jupiter's atmosphere gradually slows your plunge. Nearly 10 hours later, your body finally stirs things up around the town part of Jupiter, which is believed to be made out of metallic hydrogen. There, the temperatures are higher than the outer layer of the Sun, and tensions reach around 2 million Earth atmospheres. The climate is so thick it transforms metallic hydrogen into a fluid. In conditions like Jupiter's interior, where there's practically zero oxygen available, your body would go through a process called carbonization. Without oxygen to support the standard processes of rot or decomposition, the body's organic matter undergoes a chemical change. This happens at high temperatures and involves the breaking down of organic compounds into carbon-rich byproducts like charcoal. The massive pressure would apply a force comparable to around 650 million pounds per square inch psi, pushing down on each square inch of your body, or the piece of charcoal it's transformed into. But let's imagine your body stays in salvageable shape, consisting mostly of water and water particles with strong bonds that resist external forces trying to push the particles closer together. Even under extreme pressures, water holds much of its volume and density, making it almost incompressible. At one point, the density of your body would match the density of the surrounding environment. From this point on, you no longer fall and your body floats in place. Although we still don't know for sure what Jupiter's core is like, an alternative theory is that it's solid, almost like a rock, weighing 14 to 24 times the mass of our planet. In the next couple of years, science will uncover more about the mighty gas giant, and perhaps these discoveries will change our view of gas giants and their place in the vast universe. Until then, we're left to wonder what secrets the planet holds, a divine wonder about the edge between a planet and a star. Many years of extensive investigations have demonstrated exactly how surprisingly complex Jupiter is. Recently, 12 additional moons orbiting the gas monster have been discovered. The total number of satellites around Jupiter is now 92, more than any other planet in the solar system. The latest moons found range in size from 1 to 3.2 kilometers. A majority of these moons have broad orbits, with 9 out of 12 taking over 550 days to complete one revolution around the planet. Scientists believe that because these far-off moons move in the opposite direction of Jupiter's rotation, they could be captured asteroids. It has long been believed that Jupiter acts as a protective shield, defending our planet from space threats. In the past, astronomers even suggested that this was one reason life got a chance to develop on Earth. But recent discoveries have raised doubts about Jupiter's role as Earth's divine gatekeeper. Long-period comets, which originate from the distant reaches of the solar system and take centuries to orbit the Sun, typically enter our neighborhood. However, due to Jupiter's gravitational influence, most of these fast-moving cold objects are flung away from the solar system before they approach Earth. So, the chances of significant long-period comets slamming into our planet are incredibly rare, occurring over millions or even billions of years. Jupiter's presence plays a crucial role in protecting Earth from these potential impacts. However, the gas giant's gravitational powers have both positive and negative implications for life on Earth. On the one hand, its immense gravity prevents nearby asteroids from accumulating and forming into a planet. This led to the formation of the asteroid belt, an array of different small rocky fragments scattered between Mars and Jupiter. But today, the gas giant's gravitational pull continues to impact asteroids, causing some to stray toward the Sun. This shift in their path increases the likelihood of collisions with Earth. We've already seen this in the past. In 1770, Lex's comet passed within about 1 million miles of our planet, an extraordinary closeness on a cosmic scale. Scientists believe this comet had originally come from the outer regions of the solar system and had a close encounter with Jupiter, which diverted its path toward Earth. After completing 2 orbits around the Sun, The comet returned to a point of proximity to Jupiter 9 years later, which then ejected it from the solar system. The Jupiter shield hypothesis, supported by past virtual encounters, suggested that the gas giant shoots countless long-period comets out of the inner solar system, and this theory even predicted the comet Shoemaker-Levy 9 striking the fifth planet in 1994. However, computing resources weren't as powerful as they are today, and researchers had to make a lot of calculations. Today, we have data that includes a larger number of short-period comets and near-Earth asteroids that intersect Earth's orbit compared to long-period comets. New simulations show a different picture. Jupiter's powerful gravity interacts with the asteroid belt, causing gravitational resonances that clear out rebellious asteroids and divert them inward. Collisions between asteroids can also contribute to this process by scattering rocky fragments into turbulent zones. The inner edge of the asteroid belt is particularly influenced by a phenomenon known as mean resonance, which drives material into the inner solar system. Jupiter's current mass allows it to both divert comets toward Earth, as seen with Lex's comet, and actually remove many of them from the inner solar system. If Jupiter had only 1/5 of its current mass, it would still pose a threat to comets, but it would lose the ability to remove many of them, leading to a higher impact rate on Earth. The frequency of impacts plays a significant role in the long-term development of life on a planet. Earth's geological record shows that an impact rate of one major collision every 100 million years gives enough time for the biosphere to recover and flourish. However, a higher impact rate occurring every few million years could devastate the planet, disrupting the development of a new biosphere. Some scientists believe impacts with Earth are also how water was brought here. But what about water on Jupiter? Water vapor was first detected on Jupiter in 1995, a discovery made by the Galileo spacecraft, which conducted extensive observations and measurements of the planet and its moons. The onboard instruments of the Galileo spacecraft, particularly the near-infrared mapping spectrometer, detected the presence of water vapor in the planet's atmosphere during its close flyby. Recent data shows that water makes up roughly 0.25% of Jupiter's atmosphere over the planet's equator. While this may not sound like much, it's actually an enormous amount of water. Jupiter, likely the first planet to form in our solar system, contains a vast amount of gas and dust that didn't become part of the Sun. Understanding how much water is present in Jupiter is crucial for scientists studying the formation of the solar system. Recently, a team of researchers used telescope data to find a significant presence of water within Jupiter's famous Great Red Spot. Launched by NASA in 2012, the Juno spacecraft currently orbits the gas giant, taking close-up photos of its clouds, equipped with advanced instruments. The spacecraft has now uncovered even more evidence of water on Jupiter. Since this enormous gas giant holds over twice the combined mass of all the other planets in our solar system, even small amounts of water on such a vast planet add up to a significant amount, far surpassing the amount of water found on Earth. Water in the gas giant's atmosphere is also why Jupiter, just like Earth, has its own fascinating displays of lightning, 100 times brighter than terrestrial lightning, and peculiar hailstones. Lightning has been detected in the planet's water clouds, where water droplets collide with electrically charged ice crystals. However, the Juno spacecraft has also spotted faint lightning at higher altitudes in the atmosphere, where temperatures drop to around -87 degrees Celsius, too cold for water to exist in its liquid form. So, how does lightning occur under such conditions? The answer to the mystery lies in ammonia, a major component of Jupiter's atmosphere that acts as a natural coolant in the upper atmosphere. Water ice crystals mix with ammonia fumes and melt these ammonia droplets. They then crash into other ice crystals from below, creating an electrical charge that produces lightning. Below the ammonia ice clouds, the ammonia water droplets undergo continuous development until they become too heavy to remain suspended in the air, resembling large hailstones like we have on Earth. Scientists believe these mushball-like objects fall deeper into Jupiter's atmosphere. But now we must travel even further. More profound into Jupiter's deepest layers, it was trusted that our nearby planet group's giant universes all have a rough core. This was the accepted hypothesis for quite a while. However, as of late, researchers have started to doubt this hypothesis. Using Juno's orbit data, researchers are still studying how matter is distributed inside Jupiter, and later discoveries have disclosed a startling secret lurking inside the gas monster's center. Jupiter's core has incredibly high pressures, much greater than on Earth, and temperatures as hot as 20,000 degrees Celsius. To grasp these conditions, researchers use strong lasers to compress samples and replicate the planet's pressures in a lab. The Center for Matter of Nuclear Tensions at the University of Rochester is at the very front of this research. The density of materials in Jupiter's core depends on their composition and physical properties, and recently, researchers have found that Jupiter's core isn't as compact as they thought. Deep inside its inner regions, only 18% of the material is rough. Jupiter is overwhelmingly made up of hydrogen, representing around 90% of its composition, along with about 10% helium and trace amounts of other elements. In the outer layers of this gas giant, hydrogen exists as a dull and transparent gas, in the same form as it exists here on Earth. As you dive deeper into Jupiter, the rising air pressure changes hydrogen into a strange, thick liquid that behaves like a metal. So, what is this substance? Substance roughly 10% of the way towards Jupiter's core along its radius. The massive volume of hydrogen gas that forms the planet's atmosphere becomes packed into an exceptional structure known as fluid metal hydrogen. Fluid metallic hydrogen has properties like water, with low density, astounding electrical conductivity, and effective thermal conduction. Inside Jupiter, this plentiful substance changes the planet into one huge generator. On Earth, elements exist as solids, fluids, or gases depending on temperature and pressure. While hydrogen is commonly a gas on our planet, it can be packed and cooled artificially to turn into a fluid or solid. However, even in these states, hydrogen retains its nonmetallic nature, poorly conducting heat and electricity. Conversely, metals excel at conducting heat and electricity because of their atomic structure. Deep inside the gas giant of our solar system, hydrogen undergoes extreme temperature and pressure, which allows for curious states including fluid metallic hydrogen. The molecules under these conditions shed their electrons, resulting in a mix of free-floating hydrogen nuclei and electrons. This electron mobility resembles metal conduction. There's a theory that Jupiter's core may be filled with vast expanses of this substance, and based on past estimates of the Jovian core's mass, it may be 12 to 15 times more massive than our planet. A 40,000 kilometers deep layer of fluid metallic hydrogen, combined with Jupiter's rapid rotation of around 10 hours, produces a giant magnetic field that extends an astonishing distance of 725 million kilometers. This magnetic field remains the largest in our solar system and contains mysteries of its own. Investigating areas over 320 kilometers deep into Jupiter's atmosphere, researchers have identified a newly discovered region known as an extraordinary blue spot. This is not to be mistaken for Jupiter's Great Red Spot. Scientists knew that the Jovian magnetic field was complex, but they had no clue how strange it was, and it has something to do with the extraordinary blue spot. The Jovian magnetic field is 20,000 times stronger than Earth's magnetic field. But now, researchers have found that its strength is unpredictable. Unlike Earth's dipolar magnetic field, the gas giant's magnetic field originates from a broad region in the northern hemisphere and re-enters near the South Pole. Scientists have also identified a concentrated region just south of the equator. The extraordinary blue spot resembles a second Jovian South Pole situated near the equator. The massive storm that has raged for decades is probably caused by the presence of high concentrations of ammonia in the atmosphere. The strength of the magnetic fields in the extraordinary blue spot fluctuates by up to 1% each year, strengthening and weakening across various regions. By the end of the lengthy Juno mission in 2025, researchers will have enough evidence to evaluate their hypothesis. As research continues, we're going to encounter new mysteries about the gas giant. Since the extraordinary blue spot and the Great Red Spot are situated at the same latitude, it's possible the two phenomena are somehow connected. Gas giants are typically characterized by their high temperatures, especially in their upper atmospheres. In our solar system there are two such giants, Saturn and Jupiter. However, Jupiter doesn't have a consistently high temperature throughout its entire structure. The planetary system's largest planet is primarily known for its massive storm, twice the size of Earth, the Great Red Spot. But the gas giant has other spots too. The extraordinary cold spot is nearly as large, and researchers have been observing this phenomenon for years. At its largest, the spot is roughly 12,000 by 24,000 kilometers across. But unlike the famous red spot, this peculiar atmospheric feature stands out as a region of significantly colder temperatures compared to its surrounding environment, around 200 degrees Fahrenheit cooler than the surrounding atmosphere. The extraordinary cold spot is unpredictable, vanishing and returning intermittently. Researchers have found that this phenomenon's recurrence is triggered by the planet's auroras. Due to this connection, the spot's age is roughly equivalent to the age of Jupiter's polar lights, which spans millennia. Jupiter's auroras, like Earth's, are created by charged particles interacting with the planet's atmosphere near the poles. However, Jupiter's polar lights are more stable and intense, as they receive particles from both its moons and the Sun. New discoveries show that these auroras transfer energy to Jupiter's atmosphere, creating a temperature contrast between the upper and lower regions. This temperature contrast leads to the development of a swirling vortex, causing a cooler patch distinct from the aurora and its surroundings. Earth also experiences similar effects, but the combination of factors like Jupiter's rotation, which holds heat in specific regions, and the varying nature of these events makes the occurrence of auroras on our planet less stable. Another discovery made about the gas giant was that, contrary to popular belief, Jupiter doesn't actually orbit the Sun. The center of gravity between Jupiter and the Sun doesn't reside within the Sun itself. Instead, it exists at a specific point just above the Sun's surface in space, where a smaller object orbits a larger one. Both objects circle around a combined center of gravity. Consider Earth and the Sun, for example. In this case, the center of gravity is so close to the center of the larger object that its effect is hardly noticeable. The larger object seems stationary, while the smaller object follows an almost perfect circular path around it. The same happens when the International Space Station orbits the Earth. Both Earth and the ISS circle around their common center of gravity, even though our planet appears entirely stationary, while the ISS seems to orbit Earth in perfect circles. This principle generally applies to most planets in our solar system. Even Saturn has little effect on the Sun's position in space. However, when the mass between two objects like Jupiter and the Sun is so large, everything changes. The massive size of Jupiter causes the center of mass, known as the barycenter, to exist 1.07 solar radii away from the Sun's center, roughly 7% of a solar radius above the Sun's surface. This means that both the Sun and Jupiter circle around this specific point in space. Our ancestors knew the immense size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system, and 37.8 times the mass of Earth. Jupiter's volume is 1,318 times bigger than our planet's. But today, we've developed technologies that help us learn more about the gas giant than just its size and mass. Astronomers give a lot of attention to the study of Jupiter, as our planet's future depends on it. The latest data we have shows that right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the inner solar system by astronomers due to its massive gravity well and where it orbits in the inner solar system. The gas giant has taken several huge impacts from asteroids that could have struck Earth in the past, such as Shoemaker-Levy 9, which collided with Jupiter as it broke into pieces in 1994. Yet, the planet's gravity isn't always protecting us. Alongside Venus, it influences Earth's climate every 11 years. Gravitational variations between Earth, Venus, and Jupiter bring us unseasonably cool winters and warm summers. Droughts become intense and rains cause floods. Scientists say we're currently somewhere in this cycle, and if something goes wrong with Jupiter, it could affect Earth in a major way. So, what is the strange thing happening with Jupiter? For once, its most famous storm seems to be contracting, and we have no idea what that will mean for the planet. The Great Red Spot is an enormous anticyclonic storm on Jupiter. The biggest tempests on Earth are in excess of 1,600 kilometers across, with winds reaching up to 320 kilometers per hour. Yet these storms fail to measure up with the Great Red Spot anticyclone, which is around 16,000 kilometers in diameter. The colossal storm is revolving around Jupiter at 650 kilometers per hour. Stargazers found the Great Red Spot in the 17th century, and researchers still study this phenomenon. The unmistakable shade of Jupiter's Great Red Spot has been a mystery for quite a while. Certain researchers believe the storm is colored by complex organic compounds, which the tornado lifts from within the planet into the upper layers of the atmosphere. Others think the corroded color comes from sunlight breaking down various chemicals in the anticyclone's upper atmosphere. If this is the case, the storm isn't entirely red at all, and what we could see is just a kind of burn from the sun at the top of it. Another interesting question is why the anticyclone endures so long. Researchers have suggested this is due to Jupiter's composition, which is primarily hydrogen and helium. The gas giant has no solid surface to frictionally slow the storm down. On Earth, friction decreases wind speed near the surface, which slows down storms. However, different planets in our solar system aren't like Earth. Saturn, for instance, isn't rocky and storms there don't last as long. The biggest storm on Saturn, the Great White Spot, covers a few thousand kilometers. You can consider it a white oval when viewed through a telescope. This spot appears every few years and then disappears with almost no trace. The large dark spot on Neptune, which was discovered in 1989, was also shown to be temporary. The winds around the storm reached supersonic speeds of up to 2,400 kilometers per hour. The huge dark spot was constantly changing its shape and size. With that much activity, the storm was obviously not going to die down, but in 1994 it vanished. But let's return to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019, taking pictures of the storm to help determine its structure. Using Juno's data, researchers created a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much further than previously thought. On Earth, a storm of this size would rise above the International Space Station. Experts say that if seen from above, the hurricane would resemble a massive pancake, albeit a very thick one, extending 500 kilometers deep into the upper atmosphere of Jupiter. This is 50 to 100 times deeper than Earth's oceans. The storm is powered by airflows that go far deeper, about 3,000 kilometers. Researchers are still trying to understand how these currents travel so far. There's just one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the air currents. This is completely different from what happens on Earth, where atmospheric phenomena are usually driven by water vapor, condensation, and sunlight. We would likely see something quite different inside the Great Red Spot if we could get there. The gravity there would be immense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and extended, and thanks to this effect, scientists detected tiny earthquakes, 0.01 millimeters per second, and were able to work out the gravity inside the storm. It turned out to be incredibly strong. So, if a mysterious planet were hiding at the bottom of the anticyclone, scientists found no planet there, just a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its shape from oval to round and contracted considerably. Previously, 3 Earths would fit inside the giant storm, but now only one. Looking at these Hubble telescope pictures from 1995, 2009, and 2014, you can see how the Great Red Spot has contracted in just 19 years. So, why is the storm on Jupiter contracting, and do we have anything to worry about if the storm vanishes? According to specialists, something in the planet's atmosphere is killing the storm. An unknown force is destroying the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that seemed to be a wave stripping off its eastern side. The Juno spacecraft also took a picture of red chips breaking off from the spot. Scientists confirm that arrangements of different shapes are indeed breaking off from the Great Red Spot and dispersing into space. These large pieces, up to 100,000 kilometers in size, are about the size of Portugal or Iceland. Computer models show that this is a very common phenomenon in Jupiter's complex atmosphere. It might occur due to the merging of the Great Red Spot and smaller storms on Jupiter. Anticyclones are drawn to other anticyclones, and opposing energies like typhoons and anticyclones repel each other. The merging of anticyclones is a long process. First, a smaller storm becomes a small lump close to the larger one, then the larger storm merges with the smaller one. But when anticyclones meet with typhoons, something else happens. A clockwise rotation of an anticyclone and a counterclockwise rotation of a cyclone initially brings them to a sudden stop. Then, the motion resumes with incredible power, dispersing the storms in every direction. A small anticyclone wouldn't merge with the Great Red Spot but would break into pieces instead, and these bits of different shapes would then separate from the storm. This is what astronomers believe they are observing, and the Great Red Spot is still contracting. According to researchers' calculations, it could vanish in about 20 years. Jupiter is unlikely to be affected, but there may be some irreversible cycles that the storm was preventing. The reality of the situation will eventually come out. What will happen when the storm totally vanishes? Based on data from the Hubble telescope, the typical wind speed around the red spot increased by 8% from 2009 to 2020. This means the anticyclone isn't losing momentum and may increase in size once again, or it could be replaced by another storm. In 2003, three small oval white vortices on Earth merged, and by the end of 2005, a new tropical storm became red. Astronomers called it the Little Red Spot. In 2006, the Little Red Spot came into contact with the Great Red Spot. Although this was a slight collision, it significantly impacted both hurricanes. But how will the two storms interact in the future? To figure things out, NASA's mission Juno was extended for several years in 2021. The spacecraft will monitor mysterious polar storms, the planet's magnetosphere, and its incredible red storms. Jupiter continues to be studied by the Hubble and Webb space telescopes, as well as many ground-based observatories. Something recently happened that caught everyone's attention. NASA's Juno spacecraft, still out there exploring space, received an FM radio transmission from Jupiter's moon Ganymede. This is the same type of signal that you would find here on Earth. In fact, we use this signal regularly and know it as Wi-Fi. Did we just get an alien radio broadcast from Ganymede? To figure that out, we need to learn more about this frozen alien world. Ganymede is the largest moon in the entire solar system. If it were orbiting the Sun, it would be considered a planet, being bigger than Mercury. Although Ganymede doesn't have an atmosphere, it is the only known moon to have a solid magnetosphere, which sometimes produces auroras that are influenced by the moon's underground saltwater seas. The shaking seen by the auroras provides scientists with evidence that the underground seas on Ganymede are potentially liquid and extremely salty, far salter than Earth's seas. The FM signal that came from Ganymede originated from electrons in electromagnetic fields, a process that makes the electrons spin and impact much slower than their twist rate. The Juno spacecraft detected the 5-second radio burst in late 2020 when the moon crossed a polar region of Jupiter, where the gas giant's magnetic field interacts with Ganymede. So, could there be life on Ganymede? Well, we know for sure the signal didn't originate from alien life. It's also freezing on Ganymede, with temperatures around -186 degrees Fahrenheit. However, during one of its flybys, the Galileo spacecraft detected a thick stream of molecular hydrogen escaping from the moon's very thin atmosphere. This means that there is a lot of oxygen either trapped or floating above its icy surface. Molecular hydrogen is the lightest molecule, and Ganymede has a weak gravitational field, so the hydrogen escapes and the molecular oxygen stays behind. Some researchers say that Ganymede could have as much oxygen on its icy surface as Earth has in its atmosphere. So, could Ganymede have everything needed for life to exist in its subsurface seas? Some researchers think the pressure at the bottom of any sea there would be so high that it would turn to ice. However, a mission is needed to learn more. Despite this, Ganymede is not the best candidate for life. In fact, there is another moon orbiting Jupiter that some researchers are calling the most livable place in our solar system. Europa is a frosty white moon with earthy streaks on its surface, and has a frigid covering that could be from 2 to 20 miles thick. It's the smoothest surface of any other object in our nearby planet group, and you wouldn't find any mountains or pits here. Under the frosty surface there would be a huge underground saltwater sea, which could be 2 times the volume of those on Earth. Europa is freezing, with an average temperature of -260 degrees Fahrenheit, which keeps the cold hull as hard as stone. In any case, might life exist here? It's conceivable. At the beginning of the space age, it was felt that all life relied upon the sun, and any object too far from a star would be a frozen wad of ice, incapable of supporting life. However, finding flourishing environments at the bottom of Earth's seas, depending on aqueous vents, changed all that. Now we know life is quite resilient and can survive totally disconnected from the energy of a host star like our Sun. It's critical to understand this, as Europa could harbor basic microbial life in fluid seas under its frigid shell, and this life could be getting by from the same kind of aqueous vents. So how do we know that Europa likely has the fluid water required for life to flourish? The Galileo spacecraft, which flew by in the 90s, revealed evidence of a vast, most unfathomable global subsurface sea. Even though the moon should be a solid block of ice, the water on Europa doesn't freeze completely because it's constantly stirred by strong tidal forces as the moon orbits around Jupiter. At the same time, those tidal forces cause Europa's core to generate heat. Researchers are excited because this global sea is believed to be in direct contact with surface ice and the moon's silicate mantle. This unites everything required for a livable climate: fluid water, a source of energy, and a supply of minerals and nutrients that life needs to thrive and survive. We know some microbes or extremophiles like tardigrades can endure extreme conditions, and just perhaps Europa's secret sea could harbor these types of life forms. Between 2014 and 2016, scientists gathered evidence that there may be fluid water on Europa. Hubble Space Telescope images showed evidence of gigantic geysers of water vapor, exactly 62 miles high, ejecting from the surface over Europa's south pole. Although some scientists are confident we will find out soon enough, NASA plans to send a probe to Europa by 2025. The spacecraft, known as the Europa Clipper, will investigate whether this frigid moon has conditions suitable for life. The $2 billion solar-powered probe will fly by Europa 40 to 50 times, using a number of innovative instruments to study the moon's icy shell and the sea below it. Will it find life? The truth will come out eventually. And what about the Jupiter moon Callisto? Could life exist there too? Callisto is the second-largest Jupiter moon and the third-largest moon in the solar system. It's almost exactly the same size as Mercury, but with a surface temperature of -218 degrees Fahrenheit. It was once thought to be a dead moon because of its old, cratered surface. In fact, it has more craters on its surface than any other object in our solar system. If you have numerous pits on the surface of any celestial object, it suggests that geological processes are probably dead. However, Callisto also orbits too far away from Jupiter to be impacted by the gas giant's magnetosphere and heavy gravity. Nevertheless, Callisto may also have an underground sea, and the satellite's frigid shell may be acting like a cosmic blanket, protecting this underground sea. It's not clear whether this sea could harbor life because the surface is so old. The best way to find out for sure what's going on with these icy moons is to send a probe. NASA and the European Space Agency are building the Jupiter Icy Moons Explorer JUICE, which is scheduled to launch sometime in 2022 and begin a 7.6-year journey to Jupiter, arriving in 2029. We've all heard of the James Webb Space Telescope and the astonishing potential it holds to find habitable exoplanets, but the JUICE probe is going to carry the most powerful scientific payload ever sent to the outer solar system. This includes 10 state-of-the-art instruments and will perform a test using the spacecraft's communication system with ground-based instruments during the initial part of its long-term mission. The JUICE probe will conduct 30 targeted flybys of the three icy moons, Callisto, Europa, and Ganymede, studying them in close detail by looking at their gravity-magnetic interactions and determining whether liquid water indeed exists beneath each one. It will then investigate whether these seas could hold the organic components vital for life, or even life itself. There's another interesting moon that has been getting the attention of scientists recently, but it's not in Jupiter's orbit. However, we think it's worth focusing on if we're talking about finding life in the solar system. In 2019, NASA revealed that the sea on Saturn's moon Enceladus contains the building blocks for life. This enormous water sea is about 6 miles deep and lies under a frigid exterior that is 19 to 25 miles thick. Images of massive plumes of water vapor erupting through cracks at the south pole of Enceladus were captured by the Cassini spacecraft, showing there must be an underground sea. These plumes were analyzed by scientists at NASA and found to contain water vapor, ice, salts, methane, along with basic and complex organic molecules, stuff commonly found in living systems. The latest study of Enceladus shows the Moon is more geochemically complex than previously thought, and carbon dioxide is being driven by chemical reactions on the seafloor of an internal sea, further aiding the possibilities of the Moon hosting some sort of life. On Earth, oxygen-breathing animals consume energy in organic matter like glucose and oxygen to make carbon dioxide and water, and oxygen-breathing microorganisms can process hydrogen to make methane. NASA's Cassini's ion and neutral mass spectrometer detected methane, carbon dioxide, ammonia, molecular nitrogen, and atomic hydrogen in the plumes, and atomic hydrogen would indicate that free energy is available in the vast expanse of Enceladus cracks in the ice where the plumes emerge. These plumes have temperatures warm enough to suggest that the sea is being heated by the Moon's core. These aqueous vents could be similar to those found on Earth's oceans and are hotspots for life. A group of scientists now wants to send a probe to the Moon to explore further. It's called Oranda and it would cost $22 billion. The probe would orbit Enceladus for 200 days, which won't be easy considering Saturn's giant gravity field. Oranda will fly through these plumes of vapor, which will then funnel into science instruments at high speeds. But this probe won't just orbit the Moon, it will also land on the surface. Once the landing site is found, the probe will switch to a lander mode. 2 nuclear power sources will keep Oranda running on the Moon's surface for up to 18 months, while it sends data back to Earth. Our solar system began as a disk of dust and gas about 4.6 billion years ago. The first planets to form were the gas giants, Neptune, Uranus, Saturn, and Jupiter, which formed around the same time as the rest of the solar system, about 4.5 billion years ago. Jupiter's powerful gravity pulled in huge amounts of gas and dust from the disk before the other planets formed. It was the first and the largest. Jupiter is mostly made of hydrogen and helium, around 90% hydrogen and about 10% helium, nearly the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant just isn't massive enough for gravity to trigger nuclear fusion. The beautiful swirling clouds and storms that you see in pictures are found in the lower atmosphere, about 31 miles thick, and are made up of ammonia, ammonium hydrosulfide, and water, which form the characteristic red and white bands. When you look at Jupiter, you might think it must have a solid surface. The truth is, Jupiter doesn't have a real surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly straight through Jupiter's atmosphere and come out safely on the other side. The extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft attempting to fly into the planet. Yet we've sent spacecraft to orbit and investigate the planet. The Juno spacecraft, launched on August 5, 2011, and arriving in orbit on July 4, 2016, is the farthest spacecraft ever powered by solar arrays. What we've learned and discovered about Jupiter is incredible. The most recent findings using data from the Juno spacecraft reveal that the bright stripes of swirling gas and dust you see in Jupiter's atmosphere. Jupiter's air was found to extend 1,800 miles deep and hold so much gas that the mass is multiple times that of the entire Earth. These belts of wind stream at rates of 223 miles per hour and disturb how masses spread across the planet. It was also found that Jupiter's atmosphere is turning differently, with zones and bands rotating at speeds that vary by up to 328 feet per second. The bands, which you see in different colors, are actually moving in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, while the darker-colored bands move more slowly in the opposite direction and take more time to travel around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the pit created in the solar wind by Jupiter's strong magnetic field, swelling from 600,000 to 2 million miles and tightening into a teardrop-shaped tail, extending more than 600 million miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's interior layer, which is made up of liquid metallic hydrogen. This magnetic field was found to be nearly 20,000 times stronger than Earth's and rotates with the planet, sweeping up particles that have an electric charge. The electromagnetic storms they create are so strong that they can be heard by amateur radio operators on Earth, broadcast toward us by plasmas and magnetic field lines. These signals are sometimes even more intense than radio transmissions from the Sun. This magnetic field traps swarms of charged particles and accelerates them to extremely high energies, creating intense radiation that bombards the deepest of its 67 confirmed and named moons and would annihilate anything that came too close. Speaking of Jupiter's moons, researchers have recently detected an FM signal emanating from one of Jupiter's moons, Ganymede. If you'd like to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments below. At this point you might be wondering, does Jupiter have a solid inner core? Investigations have found that the planet's interior moves as a single body and behaves as though it were a rigid solid, despite its liquid nature. For now we can't say for sure whether Jupiter has a solid core, but the Juno spacecraft should help determine if it exists, as well as what the mass and composition of this solid core might be. We do know that, at Jupiter's core, whatever it's made of, the pressure is about 50 times the pressure on Earth. The Great Red Spot is one of the most notable features of the planet. It's an enormous storm the size of Earth that has been raging since it was first observed in 1831. Caught between two jet streams called an anticyclone, it swirls about a center of high atmospheric pressure and rotates in the opposite direction that tropical storms do on Earth. It's the largest storm in the solar system, with winds estimated to be around 400 miles per hour. Contrast that with the fastest wind speed ever recorded on Earth, which is 231 miles per hour. One day, this great red spot could vanish completely, and scientists say it has been contracting since the 1800s. It may only last another 20 years. NASA's Juno spacecraft was able to snap stunning pictures of the planet as it passed 5,600 miles over the giant red spot's clouds in July 2017. One of the astonishing things that was found is that, deep in the atmosphere, pressure and temperature increased dramatically, compressing the hydrogen gas into a liquid. This gives Jupiter the largest sea in the solar system, made of hydrogen instead of water. Juno also captured some incredible images of the gas giant's poles. At Jupiter's North Pole, a massive persistent tornado is visible, surrounded by smaller storms ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, exactly the same thing was found, with Juno doing a flyby and using infrared cameras to image a tornado the size of the entire USA, with 5 other tornadoes swirling around it in a geometric pattern. These storms also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to detect these hotspots when it accidentally flew through one on its way to a planned destruction on Jupiter's surface when the spacecraft was almost out of fuel. NASA intentionally sent the spacecraft on a one-way dive into Jupiter on September 21, 2003, to protect the moon Europa, which some believe has a subsurface ocean that could harbor life. It's worth noting that we should probably be thankful for Jupiter's size and the strong magnetic field it generates, because it's possible that Jupiter has protected Earth from certain destruction. People were laughing at the idea of an asteroid or comet hitting Earth in the late 1980s and early 1990s. However, something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Toll on March 18, 1993, using the Schmidt telescope at Mount Palomar. Researchers calculated that the comet was originally 1 to 1.2 miles wide. However, tidal forces from Jupiter's strong gravity had broken the comet into more than 20 pieces as it made its close approach to the planet in 1992. But the biggest discovery was that the pieces were about to crash into Jupiter. Fortunately for NASA, its Galileo orbiter was still en route to the gas giant. Many Earth-based telescopes and orbiting spacecraft, such as the Hubble Space Telescope, focused on the spectacular event that was about to unfold. The pieces of the comet were arranged like a cargo train and slammed into Jupiter's atmosphere, releasing the power of 300 million nuclear bombs. The fragments created enormous dark spots in the clouds that measured 1,200 to 1,900 miles, and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this size hit Earth, the results would be devastating, with impacts sending dust and debris into the atmosphere, cooling the climate, blocking sunlight, and plunging the entire planet into darkness. This historic Jupiter comet impact provided planetary defense. But fear not, this type of crash is extremely rare, and researchers say it probably only happens every 6,000 years. Or does it? On August 7, an amateur astronomer was looking at Jupiter through his telescope when he caught an asteroid slamming into the planet's atmosphere, making a white flash visible in the clouds. Some scientists say these impacts are inevitable, given the amount of debris floating around in space and Jupiter's massive gravity pulling in anything that gets too close. We could say that Jupiter is like Earth's older sibling, possibly shielding us from asteroid impacts. We've learned a lot about Jupiter and how its atmospheric layers are structured, and we've also been able to image the planet in striking detail, capturing images at the right moment for clarity, a technique called lucky imaging. The highest resolution image of Jupiter ever seen was taken in thermal infrared light. In the photographs you can see the planet's natural banding. Bright areas are clear air where heat from inside the planet can escape, and darker areas are where thick clouds block the heat from escaping. This shows that the interior of Jupiter is extremely hot, with heat left over from its formation billions of years ago. When observing Jupiter through the Hubble telescope, what you see is sunlight bouncing off the cloud tops. With these amazing images, we're learning more and more about Jupiter every day, and we're not done yet. Juno is still on its mission, and is only about 1/3 of the way through its planned mapping of the planet. There are still reasons to believe that Jupiter may have a solid core, wrapped in a layer of metallic hydrogen. We're certainly going to get more incredible pictures of Jupiter soon, and continue to unlock the mysteries of the largest planet in the solar system. So make sure to stay tuned here to see the latest stunning images of Jupiter.